We next consider the problem depicted here. We have a radioactive sample that has such a radioactivity that 94% of the activity of the sample will remain after 1 millennium. If you start with a certain activity, you'll have 94% of that activity after a millennium. Now, if the initial rate is 5 decays per second, we want to know what the rate is after 5, 10, 15, and 20 millennia, and how many total decays do we have during that time. We can zoom back a little bit and look at a solution to this problem. In the first place, if 94% of the sample remains after 1 millennium, then after 2 millennia, let's say, well, after the first millennium you're going to have 0.94 of the original rate, and after another you're going to have 0.94 of that. That means you'll have 0.94 to the second power. So if t was 2 for 2 millennia, your rate at 2 would be your original rate, whatever that is, times 0.94 raised to the second power. After another millennium, well, after 3 millennia, first millennia you're down to 0.94, then you're down to 0.94 of that after the second millennium, and after the third you're down to 0.94 cubed. So that R of 3 would be your original rate times 0.94 to the third. And if t is your number of millennia, then the rate after t millennia, you're going to apply that 0.94 t times, and you're going to get a factor of 0.94 to the t, which is going to be multiplied by the original rate. Now, after 5,000 years, if the original rate is 5 decays per second, so that you'd have 5 decays per second for R naught here, what's your activity going to be? Well, you're going to have R of 5 for 5,000 years, again assuming that 1 unit of t is 1,000 years or a millennium. You're going to put 5 in for t, you're going to have 0.95 to the fifth, which is about 0.71 or 0.72, something like that. You multiply that by 5 per second, I guess it's 0.73 because you get 3.65 decays per second. After 5,000 millennia, that's going to be the activity of your sample. Then after 10 millennia, well, you raise the 0.94 to the 10th, substituting 10 in for t both places, and you end up with 2.71 or 2.7 decays per second. And then after 15 and 20 millennia, you're going to end up with 2 per second and 1.45 per second. Now, I haven't been real consistent with significant figures here, being a little bit sloppy with significant figures, and you should understand what I mean by that, and don't be distracted by it, and don't imitate my carelessness here.